Good morning, good afternoon, and good evening. We have factoring day 5 today, and we're going to be looking at some special cases of factoring. Let's start with number 1. First thing we always do when we factor is we look for a GCF, but hopefully you'll notice that y squared and negative 16 don't have anything in common, so I can't pull out a GCF for this first one. So as we move on to my Xbox method, I'm hoping that you'll see we do have an a term. Even though I can't see it, I should know that there's a 1 out in front of that y squared. And I do have a c term, which is my negative 16, but I'm missing a b. So let's try and do this Xbox method anyways. A times c, 1 times negative 16, is just going to get me a negative 16. Since I don't have a b term, I should know that my b must be 0. So what multiplies to negative 16 and adds to 0? After a few trial and errors, you should see that your numbers are negative 4 and positive 4. Multiplies to negative 16, they're opposites, so they add to 0. So my answer is just going to be y minus 4 for one of my terms, or one of my factors, and y plus 4. Now in this case, when we've got a b that's 0, we can check to see if we have one of our special cases. So one thing that we can be looking for is my y squared and 16, they have something in common. They're both what are called perfect squares. Now, if you don't know what a perfect square is, it just means that when you multiply something by itself, the result is called your perfect square. So you guys know a bunch of perfect squares already. 1 times 1, we'll start easy. 1 times 1 is going to get me 1. That's my first perfect square. 2 times 2 is going to get me 4. 3 times 3 is going to get me 9. And you can keep going with this pattern. You should know the first few perfect squares. So 4 times 4 would get me 16. 5 times 5 is going to get me 25. 6 times 6 is going to get me 36. And so on. However, you should also know that perfect squares aren't just limited to numbers. You can have a perfect square that's a variable as well, like in this case. For number 1, y squared is our perfect square, because you can write y times y, and that's y squared. So it's a variable in this case, multiplied by itself. The result is a perfect square. We get y squared. So whenever I have two terms, y squared, 16 here, that are combined by a subtraction sign, this type of problem is called a difference of perfect squares, or a DOPS problem. Now your shortcut to solving this is going to be really simple. All you do is, you know, it breaks up into two different factors. And you look at your terms. My y squared, the square root is just y, so that's going to lead off my factors. You could also plug in the square root of 16 into your calculator. So if you don't know what the square root symbol is, it just looks like that. So you could use your square root of 16, plug that into your calculator if you can't do it into your head, and it just becomes a 4. So we're going to have a 4 and a 4, and since we know we have that b term equal to 0, I know I have to have opposites. So one of them is just going to be a negative, and one of them is going to be a positive. The really quick way to do this, you didn't need to do the Xbox, you're good to go. So we're going to try that on our next few problems. So for 2 and 3, we're going to be using that method of our difference of perfect squares, or DOPS, difference of perfect squares. So for the 1 minus 49x squared, let's look at 1. The square root of 1, when I plug that into my calculator, is just going to give me 1. So I know that my factors are leading off with a 1. Both of them have 1. For my next term, the square root of 49x squared, I know that the square root of 49 is going to be 7. And the square root of my x squared is going to be x. So my term is going to be 7x. Since our b term is 0, I know I need to have opposites. So it's a plus and a minus. Doesn't matter which order you go in. You can do a minus then a plus. Either way. Now we factored it and we're good to go. We didn't need to do the Xbox method. Number 3 is going to be set up a very similar way. So we're going to break it up into its two factors. So the square root of 25x squared, square root of 25 is just going to be a 5. The square root of my x squared is going to be x. So I'm leading off both of my factors with a 5x. Now I look at my second term. The square root of my 100 over here is just going to be a 10. So I'm going to have my 10 here, my 10 here. And again, our b was 0. We know we need opposites, so I'm going to put my plus first and then my minus second. And again, we've successfully factored. Be sure to try 1, 2, and 3 on the right side of your page on your own. Number 4 is a little bit tricky. You might think that right off the bat you can do a difference of perfect squares. However, x squared is a perfect square. You could break it up into x and x. 16 is also a perfect square. You could break it up into 4 and 4. But if I look, difference of perfect squares, the key word there is going to be difference. Difference, by now we should know, means to subtract. These are not connected by subtraction. They're connected rather by addition. So I can't go through my shortcut of difference of perfect squares. So if I were to just look at my Xbox method then, I'd know that 1 times 16 gets me 16. My b is 0. There's nothing that multiplies to 16 and adds to 0. I can't use my opposites because if I said this is negative 4 and this is positive 4, that would multiply to negative 16. So in this case, there's no more factoring that I can do. My fully factored form is just going to be x squared plus 16. Be sure to complete all the problems on the right side of your page on your own for class tomorrow. Number 9 will be the last one that we go through together. It says the area of a rectangle is represented by 9x squared minus 25. Find the perimeter of the rectangle in terms of x. I always like starting this with a picture. So I know I've got myself a rectangle here. And if I'm talking about the area of a rectangle, I know my area formula equals length times width. So they gave me my area. They gave me that the area of this was 9x squared minus 25. If I wanted to set that equal to my length times width, that would really just be breaking up my area into its factors. So with that, let's try and solve this one. Let's try and factor it. Right off the bat, again, I should be looking. If you check the top of your page, 9 is one of your perfect squares. 25 is one of your perfect squares. This time, I do have that subtraction back in there. So this is a difference of perfect squares. So let's just do that really quick and easy factoring method that we learned today. Let's start. The square root of 9 is going to give me 3. So if I break this up, it's going to be 3. And then square root of x squared is just going to be an x. We're splitting that up. My 25, the square root of 25 is just going to give me a 5. So I know what I'm leading off with and ending with in both of these. And then I just need my opposites. I'm going to put my plus first and then my minus. So I've just factored my area to get me my length and my width. So if I were to label this on my picture, it's going to be 3x plus 5, 3x minus 5, and perimeter is really the end goal here. So perimeter is just your distance around the entire shape. I've got my length, I've got my width, so I'm going to label my other length over here. I know it's the same thing. And then my other width is going to be 3x minus 5. When you add up all of these lengths, you should see that we get, let's take a look here, my 3x plus 3x plus 3x plus 3x is going to get me a 12x. And then if I do 5 minus 5, well, that just canceled out to 0. And then I have another 5 minus 5. That also cancels out to 0. So when I combine my like terms, my final answer for the perimeter is just going to come to 12x. That's my perimeter. So we used our knowledge of factoring and difference of perfect squares to break this up into its length and width, and then we were able to find the perimeter. Make sure all your practice problems are done for class tomorrow, and have a great night.